Perfect. Okay. Let's jump right in. Let's talk about number line. Let's talk about coordinate plane. So on your paper, again, you should have your notes. I just have your notes. You need to draw a number line. You can use the lines on your paper. You obviously have rulers and straight edges, so you can draw another number line. You can take it wherever you want. Let's number it. Let's go a number line that goes from -6 up to +6. So we're going to draw kind of a bigger number line than probably normal. A few more digits than I would probably assume here. So -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. Give you a little bit of time to write that down, draw it out. Okay, now, as you do that, we're going to put some terms on here as you're drawing. So what I mean by that, at -6, let's call that letter A. And let's go every 2 spots, let's put the next letter of the alphabet. So you should be able to finish at 6 with the letter G if you go every 2. So every other, basically. Well, that makes sense to you. So every other hash mark, you're going to put another dot. Going from -6 to +6. Okay, goal here today, we're going to find some distances. So we're going to practice hands-on finding distance, either with counting with your fingers or using the formula. Probably use the formula, I'd recommend it. And we're going to find distance between 2 points. Any 2 that we pick, and it doesn't matter the order we use it, but it's got to be a segment in order to use it. Okay? Should kind of draw that out. Okay, we're going to go around the room. I'll kind of pick different groups. I'm going to pick for different numbers, all that kind of stuff. So we'll start in the front of the room. Wheeler, Asia, you guys get to pick any 2 dots you want. So make your choice. But I need 2 of the dots up here. So A through G. Give me 2 letters, please. Talk amongst yourselves. Give me any 2.
Letters?
Yeah, 2 letters.
G and C.
G and C? Okay, let's go with it. All right. So on your paper, GC, I want to know the distance from G to C. Now, number 1, you can count with your fingers. Just bing, 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 it's that long. Perfect. If you want to use the formula, which we're going to do here in a second, you better guarantee what you found when counting with your fingers. It's always a fail-safe. It's nice to know 2 different strategies. So we're going G to C. It does not matter the order we go. So G to C is right here. That's G to C. It's kind of longer. Now, if you're going to count with your fingers, you're counting the gaps between all the hash marks. So as you're counting, 1, 2, 3, 4, 5, 6, 7, 8. It better be 8. 8 units long. And yeah, I said 8 units because I don't actually know what this measurement is. It's not inches or centimeters, it's just units. Does that make sense? If you count with your fingers, is it 8? I count.
Yeah.
Okay, good. All right, now, if we use the formula says whatever your endpoints are, you subtract them. So G or C, it doesn't matter the order. You guys said GC, we'll stick with that. So G and C, we're going to subtract them in that order. What was the number that came with the letter G?
6.
6. We're going to put that one first. What was the number that came with the letter C?
-2.
-2. So we have to subtract the -2. Yes, you will subtract whatever the numbers are. If they're positive or negative, you still subtract it. Now we do that. What happens to the 2 negative signs?
Makes it positive.
Makes positive, because they're side by side. And it's not because of the absolute value bar. It's because there are 2 negatives side by side. They literally cancel out. 6 plus 2 is 8. And the absolute value of 8 is still 8. It's always positive. That's what an absolute value bar does. It gives you positive numbers. So it's still 8. We're good. If you switch the letters around and you said CG, you'll still get 8. Even though the numbers will be in different order, you will still get the same answer, because when you actually subtract, you're going C minus G, that's the way you pick your two letters. You know, the C number is a -2, the G number is a 6, you still subtract it. So -2 minus the 6. When you subtract, you get -8, and the value of -8 is still 8, because it's positive. That's what the answer would always be. Do we feel comfortable with number lines?
Yeah.
Okay. Hopefully that's common sense to you. Now, here's what we're gonna do. We picked CG, right? We're gonna copy that segment to a new location on your paper, but without the use of the ruler. Without your ruler. We're gonna copy it. So here's what you need to do. First, pick up a straight edge. Now you can use the ruler if you need to for the straight edge, or you can use that little black zip tie plasticky thing. On your paper, go somewhere else and draw a segment that is clearly longer than how you drew CG. Now my CG on the board is kind of long. So, go somewhere else in your paper, draw a segment that is clearly longer than CG. And use your straight edge. Any straight edge. I'm going to use my straight edge as this crazy ruler here. We're going to copy that first construction that I kind of hinted at last week. I think it was like last Thursday or Friday. You never even got a chance to really partake. Today we're going to. So I'm drawing a segment that is clearly longer than CG. CG is kind of long for me. Boom. Yeah, that looks longer, clearly longer than CG. Okay, but again, I'm copying the CG to a new location. Put an endpoint on your segment you just drew with this. You can call it any letter of the alphabet. I don't really care. Let's call it point P. I don't really care what letter you pick. Okay, is everyone following me? You have a segment drawn, you have the point on it. Take your compass now. Now I need to grab my compass and work on those plasticky things. Compass. Okay, so you're going to take your compass. What you're going to need to do is measure out CG. So use that little gear, open up, and you're going to measure with this compass how large CG is from beginning to end on the original drawing that you have drawn. Like that. You're going to measure how big it is. So you're going to have to use that gear in the middle, make sure it's exactly from beginning to end the right size on the C to G. Right there. That's how big it is. Okay. So take your time, measure that out. Once you have that measurement, you're going to go over to your new picture and make that mark. Now how I make this mark, it's got to be really light. If your neighbor can see it right next to you, you're drawing a little too dark. But how I'm doing that, I'm putting the pike and letter P, and I'm just making the mark. If you push too hard on your paper, it'll make a dark mark, and what will happen is your compass will open by accident. It'll make a different size. So measure CG perfectly. Take that, go over to your new picture, mark the distance. You can label that point now. You label that point, let's call this point, point Q, I guess. Let's call this point Q, and you can scribble out all the rest. In geometry, we don't erase markings. We just scribble out the excess piece that we don't need. That way I can see that you're actually doing it correctly. You drew something too big, you cross out what you don't need. Do we feel comfortable with that?
Yeah.
Okay, what we're doing is we're copying segments. You can do that anytime you want. You could have put that segment anywhere. You could have attached it to this one and had it going in a different length. Because in this class, we will have to do sketches. Really accurate sketches in this class. Now draw a square. It's nice to use this, because that guarantees all the walls are the same for a square. Because you can measure it, the first one at least. We'll learn eventually other things like how to draw the perfect right angles and all that. Those are things we're going to build upon the year. I like to start easy, work our way to kind of crazy difficult ones that actually take serious effort. Okay, we're good with that. Okay, you can put the compass down for right now. You can even put it probably back in a little baggie, if you will. The straight edges you'll need though. We're gonna need the straight edges here. All right. Next thing, graph paper. Okay, you can put your name on it. This is going to be for your note purposes only. So you're going to keep this paper for the next couple days in here. Don't lose this. I don't like giving out multiple pages every day because you can't keep track. Don't lose this. This is your notes for the next couple days. Alright, so everyone's got scrap paper perfect. You can put your name on it, it's yours. Just make sure wherever you put your name on it, make sure that the Y is at the top, the X is off to the side. They are labeled correctly. Y has to be at the top of your paper. Because some people like turn it sideways. Y has to be at the top. In fact, I'm going to put my graph on the board here. Let's just do that. Let's just cut right to it. Boom, there it is. Perfect. Okay, next thing we're going to do, we're going to practice making this picture and drawing it exactly the same way that I have. You will want to use a straight edge for sure when we get to it, so don't try to freehand draw stuff. It gets a little sloppy in there. But what we're going to try to do is we're going to try to find distance, but with the coordinate plane. That was that crazy formula that we were doing yesterday with all the square root stuff. We're going to talk about square roots today, so you get a little more hands-on practice with it. Okay? All right, so moving on to the next group. So, sphere, Bree, you guys, you can pick any coordinate you want, just one coordinate. So give me the two numbers, discuss them amongst yourselves. I need a coordinate that I'm going to put on the graph. You can pick any spot you want. Okay, got anything?
2, -8.
2, -8. Like it. All right. So over in the room, find 2, -8s. In fact, I'm right on the board. Okay, 2, -8s. So find that spot right now. Talk amongst yourselves, figure out where to put it. So that everyone gets at the right location. 2, -8. There should be one dot there, label it with an A. The dot can be kind of big, not crazy big, but it can be big enough that you can see it, or your neighbor can see it. But label it with an A. A little bit of time here. 2, -8. Now, in the quadrant system, because I'm talking about the graph itself, the graph has, x-axis, y-axis, they're already labeled for you, has an origin. There's quadrants. There's 4 quadrants. Okay, where's quadrant number 1 at?
Top left,
Top, not left,
right,
top right.
tilts back.
Okay, top right. Where's 2? Where's 2 at?
Bottom line.
Bottom right? Nope.
No. Top.
Top left. Here's 2. 3. And 4. I know that seems really goofy. They number them counterclockwise. I'll explain that in probably the next section of your book, why they went counterclockwise. There's actual purpose to it, and you learn it in geometry, why they do that. All right, now why I'm bringing this up. It's nice to know the quadrants, because obviously some people have the misconception, they just don't remember. It's been a long time probably since you've had to do that. But the reason why is I refer to this a lot. What quadrant did you just put letter A at?
4.
4. It better be in the 4 quadrant. Because you went over 2, down 8. Now how I knew how to go there so fast, my graphs only go up to 12s. So if I went over 2, all I have to do is go down so I'm 4 from the bottom. Because the bottom is 12. 4 from the bottom is 8. That's how I can get to places really quick on this graph. The middle ground is messy. 6 and 7s, those are hard. All right, does everyone have A down? Okay. Anna Anderson, you guys get to pick the next coordinate, please. Any spot you like. Come to an agreement.
-4, 7.
-4, 7. Okay, I like it. Letter B, -4, 7. Draw a dot, label it with a capital B. -4, 7. These are good spots you guys pick.
Says what? Q or B?
B. B.
What?
You can label the Q. You're okay with that.
What?
You can do that. Let's make it your own letters there, Chris. Alright. Now, I like the coordinate. Okay. Wheeler, just make sure you draw these two coordinates in your graph. Okay, perfect. Now, B, what quadrant?
2.
2, better be in 2. Because you went over -4, because that's -4 on the x, so -4 over, up 7. 1, 2, 3, 4, 5, 6, 7. I'm not so fast with sevens. Can't do that too quick. Okay, does that make sense what quadrant we're in? Remember, the quadrants go counterclockwise. 1, 2, 3, 4. So you can see my board how I've labeled them. All right, take your straight edge, draw a line that connects them. Not a line, but a segment, I should say, a line segment. So use your straight edge to be super accurate. Super accurate. Straight there. A to B. A to B. All right, our goal here is to figure out the distance from A to B or B to A. I don't really care how you do it. We have a formula for it. You have to use the formula. This one you cannot count with your fingers. When it goes diagonal, 95% of the time, it will be a crazy decimal. Like it's not going to be a perfect gap. Because anytime you go diagonal, it has that option of being irrational numbers. If it was straight across, count with your fingers. If it was straight up and down, count with your fingers. That's how many spaces there are. But diagonal, it gets messy. Okay, so if you have your two coordinates written down, so now you need to go back to your notebook paper. We'll come back to the drawing here in a minute, because we're going to do some other stuff with it. We need to have the formula written down. So in your, I don't know where, in your notes, bless you, in your notes somewhere, you need to have this formula written down. We had it written down yesterday, but it's nice that you write it down again. It's nice to have more practice writing it. On test day, is one of the formulas I usually have written on the board somewhere. I don't label it, I just have it written on the board somewhere. This formula is what we use to find distance on a graph. It gets messy because you have squares and square roots, and this is where calculators come into play and how you're supposed to do it. Okay. What this is, we have to subtract the x numbers. On our two coordinates we picked, so we have two groups to pick coordinates. Which numbers up there in my coordinates are the x numbers?
2, -4.
2 and -4, it's the front numbers, right? It's alphabetical order. The x's are in the front. You can pick any of the two you want to put first, but you have to subtract those two numbers from each other, so the 2 and the -4. I don't care which number you put first. Which one do you want to do, 4 or 2 first?
2.
2, okay, so we're going to go 2 minus the -4. Yes, you always have to subtract the two numbers. I don't care if they're negative, you still subtract the negative. Okay, there's your first bubble, and we squared that bubble with the power of 2 on it. For the y's now, the y numbers, well obviously that would be the second letter, right? That's the second letter, that's your 8 and 7, negative 8 and 7 I should say. Which order do you want to write those now? 7 minus the -8, okay. So 7 minus the -8. We're squaring that, remember we're subtracting the y numbers, so 7 and the 8. And it didn't matter the order, because you're going to square it anyway. So we want 7 minus -8. Now, doing the math here. What happens to the two negative signs here? Positive, because they're side by side, so this is 2 plus 4. We're going to square that. The two negative signs cancel out, because it's negative, so it's going to be plus 7 plus 8. We have it under a radical. So 2 plus 4 is what, 6? And we're squaring that. 7 plus 8 is 15, and we're squaring that. And if you're doing that, it's nice to put parentheses around those numbers, like 6 with parentheses around it, 15 with parentheses around it, just saying. Especially if those numbers turn out to be negative, keep the parentheses on them, don't drop them like I just did. All right. We have to square them. What's 6 squared? 36. Because you're taking 6 times 6, that's what power 2 means. It takes the base times itself. That's 36. 15 squared.
225.
Yeah, that's kind of a big number. It's 15 times 15. Add those two numbers together. Stop the camera here. So if we add those two together, 225 plus 36, what do we get? 261?
Yeah.
Okay. Now, that's the distance. You need to take the square root of it. This is the part you need to get practice on with the calculator. You need to figure out right now how to type in the radical, type in the 261 and hit enter. And I want the decimal, because I know some calculators in here, like really nice calculators, I can see them in this room, may not give you the decimal of it. So if you're not getting decimals, let me know and I'll tell you how to do it. Yeah, that's the one I want. All right. Got it? Okay. So we got some numbers here. Is anyone having troubles with it? Okay. Yeah, I figured there was going to be some. See the little second key? Hit the little square button right there. Yeah. No, that one. Not the one with the X, the one without the X. So clear it out and type it again. Boom, now, yeah, okay. Sweet, yeah, these are super nice. You need to type in.
I couldn't figure it out yesterday.
Oh, here. Okay, hit mode. You're gonna go down to, scroll down to classic. Okay, enter. Classic. Now, if you ever want to go back to what I showed you earlier, then you can go back to that. Let's quit that, type it again. Now it should give you all the decimals every single time. 61. Okay, anyone else having trouble typing it in? Or it's not giving you a decimal? Okay, did it work?
Yeah.
Alright. So, what do we get?
16.15.
16.15? Okay, roughly? Okay, that's an approximation. Is that right?
Yeah.
Okay, that's the distance. It's 16 spaces. I mean, by spaces, is that there's an actual space here. So it's 16 of those little gaps plus a little bit extra. Now, it may not look like it. You can kind of hold your fingers or kind of measure and kind of see, yeah, it's about 16-ish and a little bit extra. Okay, to prove the point, pick up your ruler. Go to the metric system. So turn it over so it's metric. Metric is a little more accurate. Okay, what I want you to do is to get a feel for this. And I know this is going to seem a little weird. What we're going to do is on your graph, you're going to measure A to B and tell me how many centimeters it is. Now, if it goes past a certain marker, it's kind of nice to know that. Now, I can't do it up here on mine because mine's obviously way bigger than yours. It's exactly 5 centimeters? Like, is it spot on?
No.
Ooh.
4.9.
It's 4.6.
Okay, so it's like super close. 4.8.
Mine was right.
4.9.
Let me double check. Because we have people that think it's right on, some people that think it's close.
Oh, wait. Yeah, it is.
Yeah, it's pretty close. It's like 4.9 maybe. It's almost 5. Like I would say like really close to 5. Because remember on the metric system, it only goes 10 hash marks. So we're at about 4.9 or 5-ish. Okay, so I'm going to write that down. So this is about 4.9 centimeters. Now, what we just found out a little bit ago is that 4.9 centimeters, you know, when we measured on this, I guess your graph, is roughly 16.15 units on this graph. Because we just said A to B is about 16.5. What that is, it's how many bricks there are. 16.5 bricks from there to there. So here's what I'd like you to do, just to prove the point. Take your ruler. Put your ruler down at the bottom of the graph. Start it right here, where this is 0. Where you line it 0 right at the bottom of your graph. What I'd like you to do is count over 16 bricks. You can actually go 16 across. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So it looks like we're going to be about right here. So we're about 4 bricks past the y-axis, right? 4 bricks past. That's 16 bricks over. If your ruler's lined up, kind of right there, where it's about 16 bricks in, that's about 4 bricks past the y-axis, is that about the 5 centimeter mark?
Yes.
Yeah.
Yeah, that's what we're proving. That, what I'm trying to show you is that you measure this. You guys actually put your ruler on paper. You measure this as 4.9. I'm trying to show you that what we found with this formula is actually accurate. That we found it was supposed to be 16 bricks long, and so when we were comparing is what 4.9 centimeters is, it's about 16 bricks. It's nice to know that the formula is giving you a correct answer. It is exactly 16.15 bricks long, or 5 centimeters roughly. It's nice to see that, so that you can kind of see how it's working, so that we're not just making up fictitious numbers. We're proving the point that it is accurate. This part really gets people, like they don't understand this. This is how many bricks across it is. This is the actual distance on a ruler though. There's a difference. Make sense? Like what we can do with this? All right, put your straight edges, compasses back in the little blue bag. I'm gonna walk around, I'm gonna collect those here in a second. Make sure the little like stick, the straight edges get back in the bag. All right. Yes, you can do that. Okay, we only have a few minutes left here, so hopefully this makes sense to you. Now, we didn't get to the word midpoint today. We need this. You need your graph tomorrow. Do not lose that piece of paper you just did. Do not lose that piece of paper. We need it. It's the first thing we're going to look at tomorrow. So hopefully this is a little more entertaining today, and I think we're going to try to keep these senior angels, like not where you're at right now, but like the little pods. I kind of like the spacing. A little more room.
You actually walk in it up.
You want it back in the rows?
No, I don't like that.
You like this? Yeah, I kind of like it. There's more space. It's a little more comfortable. Exactly. Yeah, I kind of like it. I might move them around where you do like 3 pods, or I change the pods up.
Wait, stop.
Look at this camera.
Oh, you're right. Plenty of those. What color do you want? Do you want yellow, green, orange, blue, purple? I have bookmarks somewhere around here. I thought yeah, I don't think so. That's a sharp edge.
You just stare at it.